This is the reaction that occurs inside of a lead storage battery. A lead storage battery is the battery found in most automobiles. Let's go ahead and balance this reaction using the electron transfer method, starting with oxidation numbers. So lead is in its elemental form. It has an oxidation number of 0. Here we have lead oxide. Oxygen in this compound would have an oxidation number of -2. Since you have 2 oxygens, that means you would have a -4 total for the oxygen. The compound has to be neutral, so lead must be +4. Here we have HSO4 minus ion. The hydrogen would be +1. The oxygen would be -2. So for the equation here, we can see we need an overall charge of -1 on the ion. 4 oxygens gives us a -8. 1 hydrogen gives us the +1. We need to get a -1, so sulfur in this ion must be +6. H3O plus, hydrogen is +1. If we need to end up with a positive charge on the ion, then oxygen must be -2. 3 times a +1 would be a +3, and then plus a -2 would leave you with that positive charge on that ion. Next we can do lead sulfate. Oxygen will have a -2 charge, and from here we might have a little bit of an issue, so just remember the whole compound must be neutral in this case. 4 oxygens will give us a -8. So if we look at our ion table, we can see we have lead 2 and lead 4. Sulfate ion has a charge of -2. Since we only needed 1 lead and we only have 1 sulfate, that must mean this was lead 2+. If we solve our equation then, sulfur here must be +6 again. The hydrogen in water is always +1 and the oxygen is always -2. So now that we've assigned oxidation numbers, we can determine what substance was oxidized and reduced. So here we can see that lead goes from an oxidation state of 0 to +2. In order to do that, it had to lose 2 electrons. Losing electrons is oxidation. The reduction reaction also involves lead, this time from lead oxide. The lead oxide goes from an oxidation state of +4 to +2. That is reduction because 2 electrons are gained. Since our oxidation and reduction process involve the same number of electrons, we do not need to multiply either of those processes by a whole number. So that allows us to put a 1 in front of lead and lead sulfate, and then also a 1 in front of lead oxide and lead sulfate, but putting 2 1s there would change that to a 2. If we balance the reaction from here, we can see we have 2 leads on both sides, and here we have 2 sulfurs. So on this side we would need 2 sulfurs, so we need a 2 in front of the HSO4 minus. We would also need a 2 in front of H3O plus. From there, we can balance either the hydrogens or the oxygens. Let's just look at the hydrogens. We have 2 here and HSO4 minus, and we have 6 here and H3O plus. So we have a total of 8 hydrogens on the reactant side. We need 8 hydrogens over here. So we need a 4 in front of H2O. You can check the oxygens out. They are also balanced. So let's answer these questions about the lead storage battery. What chemical is oxidized? Well, oxidized means losing electrons. That was lead. What element was oxidized? Well, in this case, the chemical that's oxidized is the element lead. So that's actually the same answer. We can see the chemical that is being reduced is PbO2, but what element or ion specifically is being reduced? That is lead 4+. So that's the difference in those two questions. What is the anode in the lead acid storage battery? Well, oxidation occurs at the anode. So the anode is lead. What is the cathode? Reduction occurs at the cathode. So the cathode is lead oxide. The electrolyte for this battery happens to be the sulfuric acid. So your car battery is used to start the motor, to run your radio, to run your lights, to run your dashboard, all those kind of things that you might need an electric current for. But the reason why the battery is able to have such a long life is because once the engine is started, we have an alternator that reverses the current through the battery and charges the battery while your car is running. To wrap this up, what happens to the masses of the two electrodes as this battery is discharged? Discharged means we have the forward reaction occurring. So if you look at it, both the anode and the cathode are reactants. As the reaction goes in the forward direction, both of them are converted into lead sulfate, into a product. So this example is going to be different from the ones that we make battery diagrams for. Since the reactants are becoming products, the cathode will decrease in mass as lead oxide becomes lead sulfate. The anode will also decrease in mass because lead gets used up and becomes lead sulfate. So both the anode and the cathode are decreasing in mass. So one real-world application for this is jump-starting a car. Maybe you've had to do this before. Hopefully you followed the correct procedure. To kind of help you with that, I made a short little video.
What seems to be the problem?
My truck won't start. I think the battery is dead.
Okay, I think I can give you a jump. You have any jumper cables?
No, I do not.
You should always go on the road prepared with some jumper cables. Good thing I got some brand new jumper cables right here to use to jump start the car.
Oh.
You should always use new jumper cables to jump start the car. All right, here we go. I'm going to start by connecting the red cable to the red terminal of the dead battery. Then you connect the other red cable to the red terminal on the good battery. You're going to take your black cable, connect it to the negative terminal of the good battery. Then you want to find a piece of exposed metal to ground out the charge of the battery. I'm going to hook it right here to the frame on the truck. Alright, next you want to make sure the two cars aren't touching. Start the car that has the good battery. Alright, it's been a few minutes. You should be able to start the big truck now. Go ahead. And that's how you jump start a car. To disconnect the jumper cables, take them off in reverse order. So take the negative cable off of the car body, and then the black wire off of the good battery, and the red wire off of the good battery, and then the red wire off of the dead battery. And you're all done.